This second lesson of chapter 5, we're going to be learning about the antiderivative of 1 over x. So here it is. And this, we need to memorize these antiderivatives. If you are ever asked to take the antiderivative of 1 over x dx, the answer will be the natural log of the absolute value of x plus c. And so this is one of those, we need to memorize it. If you ever see the antiderivative of 1 over x, it's always going to be the natural log of the absolute value of x plus c. So jumping straight into an example of this, what if you were asked to take the antiderivative of 1 over 3x plus 2 dx? What I hope you remember from chapter 4 is that in some sense antiderivatives are hard, but they should be easy because you should never ever do an antiderivative that you don't exactly know what it is already. So in this problem, we have not memorized what the antiderivative of 1 over 3x plus 2 is. Sorry. We know what 1 over x is, but we don't know what 1 over 3x plus 2 is. So what that means is we want to do a u substitution. Over here on the side, I'm going to choose my u to be 3x plus 2. And you remember that we always wanted to choose our u to be something whose derivative showed up elsewhere in the problem, or it's something that was plugged into something else. Now, I know it doesn't feel like 3x plus 2 is plugged into anything, but it kind of is. It's plugged into 1 over x. It's taking the place of that x, right? So this is just a review of u substitution now. It means I'm going to say du is 3 dx. That means du over 3 equals dx. And this is now what I bring back into the problem. Remember, we primarily use the first line and the third line here. I now have the integral of 1 over u times du over 3. Then I can take that 1/3 and bring it out front. 1/3 the integral of 1 over u du. And recall what I said earlier. You are supposed to take the derivative only when it's exactly something you've memorized. So at this point, this looks just like this. So I can now say that this integral is 1/3 the natural log of the absolute value of u plus c. And the final step that we take is to plug our u back in. U was chosen to be 3x plus 2. And so this is our antiderivative. And like that's how these problems are going to go. And really what this unlocks for you is this idea that if you see something on the bottom of a fraction, a lot of times that can be your u if the derivative of that is on top. I'm going to do one more sort of example of this. So let's see here. What if I asked you to find the integral of cosine x over sine x dx? Now some of you may be looking at that going, hey, isn't that cotangent? It is. Although it's actually scarier if I ask you for the integral of cotangent, because we don't know what the integral of cotangent, we've never known what the integral of cotangent is. We know what the derivative is. We know the derivative of cotangent is negative cosecant squared x, and we'll have to think through those. But we don't know what the integral of cotangent is. So I don't know what this is. I'm going to have to use something to do this. We need to choose a u for this problem. You might originally try choosing your u to be cosine, and I'm going to kind of talk through something. I hope you guys can see this. If I choose my u to be cosine, I'm actually going to write this down. If I choose my u to be cosine x, that means my du would be negative sine x dx. I kind of want to say don't write this down because it's going to be wrong. You're going to get du over negative sine x equals dx. And what I'm hoping you guys notice is, do you notice why this doesn't work? I'm not actually going to write down the plugging in, but the reality is if you were to take this dx and put it here, it wouldn't work because you'd have two sine x's on the bottom. They're not going to cancel, right? We can sort of see that this is not going to work. Please note that's okay. I really feel like one of the biggest things you guys need to learn for doing U substitutions and doing integrals is that you're going to have to do them wrong a couple times. And that's okay. Like, don't get discouraged. If you've done a problem once and it didn't work, that's fine. When I come around in class and help you guys, the first thing I ask is, what did you try? Show me what work you already did. And if you haven't done it, it's sort of like I can't help, right? So that U substitution didn't work. We can try U equals sine x, right? That means du is cosine x dx. That means du over cosine x equals dx. And I can plug this stuff in. This will be the integral of cosine x over u times du over cosine x. I'm just pulling these things from this substitution that I'm doing. Notice the cosine x's cancel out. I'm left with the integral of 1 over u du. Right? And that integral of 1 over u is the natural log of the absolute value of u plus c. And now what was that u? That u is sine x plus c. And there's our answer. I'm going to do a little bit of foreshadowing of the third video in this sequence. In the third video, we're going to learn 4 new antiderivatives, 4 new integrals, which are basically the integrals of tangent, cotangent, secant, and cosecant. And I'm previewing one of them here. It turns out that the integral of cotangent is the natural log of sine x plus c. You'll need to memorize that tonight. I'll talk about that in the third video. For now, it is what it is. The last point that I want to leave you with here, and I'm hoping that I can keep this, sort of to under a minute. That's not going to happen, maybe 2 minutes. Is this idea that, yes, we now know that the integral of 1 over x dx is ln x plus c. That does not mean that the integral of 1 over anything is natural log. For instance, if you had the integral of 1 over x squared dx, please, please, please know that this is not the natural log of x squared plus c. This integral is something you guys have known how to do all along, right? This is the thing where we say, oh, that's x to the negative 2. So I up the power by 1. Gee, sorry. And it becomes negative x to the negative 1 plus c. In other words, it becomes negative 1 over x plus c. Yay, that's what this one is. Right? Just because x squared was on the bottom does not mean it's natural log. Natural log only shows up when it's 1 over x to a single solitary power. The only time you will ever end up with natural log is when it's 1 over x, 1 over u, 1 over a single variable raised to the first power. Even like the integral of 1 over the square root of x. Well, that was kind of ugly, sorry. 1 over the square root of x dx. It's so tempting for us to say that this is the natural log of the square root of x plus c, but it's not. If you wanted to do this antiderivative, you would rewrite it. You would rewrite it as the integral of x to the negative 1/2 dx. Then you would increase that power by 1. That would make it 1/2. You do the reciprocal of that times x to the 1/2 plus c. You get 2 root x plus c. That is the antiderivative of 1 over the square root of x. So please remember, this natural log thing only shows up when it's 1 over x. Nothing more. That's ugly. But I really want to emphasize it only works for 1 over x, 1 over u, 1 over single variable. Not squared, not square rooted, just 1 over x. Okay? So that's the end of this video. The next video is really just a review of one other thing from chapter 4 with natural logs built into it. So I'll see you in that, hopefully short video.